All right, question one. Electromagnetic spectrum here. So we want to be able to fill in and know all the different things. First is we're going from long wavelength to short wavelength. We're also going to go from low energy to high energy. All right, and then low frequency to high frequency. Frequency and energy go together. So we got visible. Let's just work our way from visible. So since this is red, then this is going to be infrared, IR. And the other way is going to be ultraviolet, UV. Since that's violet, then the one right above it is ultraviolet. And then we're going higher energy. So ultraviolet, those will burn you. So other bad things, X-rays, and then the really bad ones turn you into Incredible Hulk. Not really, not part of physics, but will damage your cells and kill you instead, is the gamma wave. Gamma ray. And then if we go the other way from infrared, we're getting less energetic. And so we have microwaves. Let me zoom in on this. And radio waves. All right. So we did it and we filled it in. All right. Which of the following bands has the lowest frequency? Well, as I just said, low frequency goes with long wavelength and low energy. And so it is radio waves. Which of the following has the highest energy? Well, I wrote that right up there. Highest energy is going to be gamma rays of that particular one. All right, certain radio frequency has 92.5 megahertz. All right, so mega, you got to know these different things. So mega means times 10 to the sixth. Kilo means times 10 to the third. You don't need to know deca. So we'll just jump down to the basic one. So then you have what it is. And then we get smaller. Centa, I guess technically you need to know centimeter. Centimeter, C, will be times 10 to the negative 2 for 100. But, I mean, well, whatever. Yeah, you should know that. Milli is times 10 to the negative 3. Micro is times 10 to the negative 6. And nano is times 10 to the negative 9th. You need to memorize these. They're not on there. We're going to give you those things in mega or whatever, and you got to know those. So memorize them, put them in there, but that's how you figure it. So that's going to be the frequency. What's its wavelengths? So we're going to do velocity equals wavelength times frequency. The speed of light is 3 times 10 to the 8th meters per second. The wavelength is what we're trying to find. And the frequency here is 92.5. Mega becomes times 10 to the 6th, and that's hertz. All right, and then solving that out, you get the wavelength equals about 3.24 meters. Right? Got to be able to turn mega into that. Can't memorize those things. All right, portion of the light, the ultraviolet spectrum has a wavelength of 125 nanometers. What's its frequency? So we're finding frequency now. Again, velocity equals wavelength times frequency. It also is moving at 3 times 10 to the 8th. They all are. And now we know it's 125, but it's nano. So we're going to go times 10 to the negative 9th. And then the frequency is what we're trying to find. It's pretty terrible enough. Times the frequency. Ooh, that's not much better, whatever. And frequency is equal to 2.4 times 10 to the 15th hertz. And you don't need to go back. That's fine. You can leave it like that. All right, electromagnetic waves, which of the following bands travel the fastest in a vacuum? In a vacuum, they're all the same speed. They're all light waves. They all travel at the same speed. All right, that's question number one.